Hello there, ladies and gentlemen, and today we're taking a look at the Soho of Zaha Hadid in China, which is a very interesting building because it has like the shape you saw already here. Like it has this several pieces of like slabs that are kind of getting narrower to the top. So we already have this done here, and we can obviously like change the parameters around and like change it and see how the form adjusts to it. And it just goes very like parametrically here in Grasshopper and Rhino. If you want to know how it works, then just follow along and let's get into it. Okay, well, I will just sketch out the things first so we can get a better understanding of how it actually works. I guess you can see my screen, perfect. So the philosophy behind it is basically we have our, we just take a few polar lines or like curves like those. Then we are defining a middle point in the things. And then we're defining like one curve here in the end as well, which can be done parametrically as well in our case. And those then get like a tweening curve in between those two, like an average in between those curves. And then we're not only doing that, but we also, if you're going to the side section, we're having those things like those, right? And then we also want to define like the structure that goes on top of it like that. And we do like also, there are also images as well, like the vertical structure, like those, like that as well. Great, so we will just start by drawing curves into the Rhino environment like that. Like with the curve command, like let's do like a few curves. Because we want to have several buildings that work on, and they can be like however you really like. They should be closed though, that's like an important thing. And we just put them into the Grasshopper environment like that. So we do like curve, like this, multiple curves, enter. And then we should be defining first just like a little offset of it as well, like, or we do like a scaling in this case. So we do scale, take the geometry, take the area of the geometry like this, and then put the centroid into the center of it, and then do it by a certain factor that we can define ourselves here in the middle, depending on how the top of the building, like the top thing needs to look. And we do like the top building relation. And we also want to create a gene pool of different ways of how it goes like up. So basically, if you do tween curve, then if we would create a series between, or like a range between the two curves, you would see like between this one and that one, you see it creates them rather good. And actually we need to graph this one here in the beginning, so it does it for all. But we want to have different heights and different sizes, so we want to have different steps amounts depending on that. So we do a gene pool, which can be found on actually in the parameter, the simple one, util, and then go under gene pool here. And we put this one into the steps amount. And now we would have different steps for the different things here, which can be very useful for our things. However, we see that like this one here gets kind of a weird vibe. That's because we're getting 5-10 different steps amounts, but we only have 3 different curves. So we need to remove a few of those factors. So we just do a list item, and we control the list length that we have here on our beginning curve. Then we do a series of that list and do the count of 3, because that's the length of the list that we have here, but we need to flatten it first. And that will give us a series of 0, 1, 2, and those will be the indexes that we need to take from the gene pool range. So now you see we can change those as we want and nothing happens, but this one obviously will still adjust those things to our liking. Great, now that we have that defined, we actually can also, I want to edit this and just make them without decimals, so because it's just like, those are just integers, like they don't have to be floating points, like points with commas after them. And then, now that we have that, we want to move them also upwards. So we just do a rather simple series of, I don't know why it's always caps lock. And we have to define the height of the floor. So we do like 3.1 meters. And we put those curves here from there. We just do the move command. And then the count will be again from the gene pool that we select only the first like 3 items in this case. That then will be used as the motion, which goes into the Z direction. And it will give us something like that, which looks kind of weird because it is. And we actually need to make this a little bit different, because otherwise, yeah, we need to actually like reverse this list here, which would give us a better result. However, this kind of looks like Christmas, and we don't really want that at the moment. And that's just because the tween factor is kind of like going like, if you go look at it, it always has the like very static things in between them. And we can go around this by using a graph like that, like this, and we're gonna use the range here, and we're just gonna use the graph type of a conic, and this would give us a more, well, we don't put it in the curve, we put it into the factor, and you see this will give us a more look that we are looking for in this case. Great. Now that we have that, we're just gonna hide the things that we don't really need. And that we have that defined, that already helps us quite a lot out with the stuff. But there are still a few things, especially about the structure, that I want to address here as well. First of all, we wanted to make those, we have those different rings, right? And we want to have, and we kind of can see it online if we are taking a look at the structure here. Oh, the tower, I need to quickly find this picture. Yeah, it's kind of shown here as well, but you also have it on this one here. For example, you have this vertical structure that goes along, like a bit of an offset along it, and then you also have just purely vertical structure as well. And we want to have basically both of them happening here in our case. So we're going to just do a simple scaled offset, I would say, and we just use the base geometry here, and we also will find out the geometry here, and we just do could also just do like a simple offset, but I think in our case it might be both fine anyway. But we do the center of here, and we use geometry of that geometry here, and we do a factor that we define again ourselves, that gives us like a curve that's a little bit with an offset. Now that we have that, we want to divide this curve by a certain amount in order for us to get those outer like column thingies. And now, and this will be like a little bit of a different thing, if you want to combine those lines that we have here together, you cannot just put this here, because this will just put those lines here together. And if you do flip curve or flip matrix in Reda, it doesn't work at all. So in our case, and this is a little bit more specific, we need to use the path mapper, which is a very complicated tool, I would say. I still also don't figure out completely yet, but what we can basically do, we can remap the paths in a certain way. So we just take this path like here, and then, for example, it graphs the numbers here in this case. But in our case, what we want to do is a rather specific operation. So if we just go to, I think just the null mapper, or even I think we can take the graphed mapper, might be more like this. We need to do a specific operation because we want to switch those things back and forth. So this stays like how it is, but then we want to have the one part like out, the last one, and we want to put in, instead of the D, we will just put in the I. And this should change those things back and forth. And as you see, it switches and flips those last things back and forth, and it gives us the desired outcome of our pieces like that. So great, now that we have that, we can also want to define the inner points as well. So just let me hide those here. And those will be defined by a grid here in the beginning. And as you see, by the way, we can always change those back and forth and around, have it to our liking, and obviously with our structure around that, which is pretty useful. Or more, that would be like more of a structure. But now that we have that, we also want to use another component, which is to create the surface, or like the just vertical things as well. So for example, if we scale this one here up a little bit, you see we also need to have some inner columns as well, which is important for the structure to work as intended. So we are going to just use the base curve that we defined here. And obviously for each of the things, yeah, they're all here. And then we also want to basically move them into this direction, but also into the other direction. So we're just going to use a series, and we want to basically move it. If I have the point here, I want to move the points move to there several times, but I also want the points move to the other direction several times. But I also want to move them into the y directions several times. So we have to create a list that kind of like makes that for us a lot more comfortable. So we're going to create a series, and we're going to create just like two numbers like that. And the steps will be like, this will be the column distance, and that will be the amount of possible columns like happening here. But now we need to, if you look at this, it would just give us like numbers that are rising, but we want to have numbers basically start at then minus 310, I guess, and then go to 0 and all the way further. So I just show you exactly what I mean by that. So if I just move this as the x direction, it would just move the points into one direction, and but I want to move them into two directions. So we do this by making an expression, and we can also just use it in Grasshopper normally, but I think expressions are a better way of having it more like visible or usable. So then we use the go in here, double click, and we use the negative of the multiplication of the column spacing and the column amounts, and divide it by 2. And this would give us, if we just take it from here and we just rename this into column spacing, and the other one will be our column amounts. And this will then be the result of that. And you see it gives us numbers from minus 320 till 300, and we actually need to just do an expression here at the count and do x plus 1, so it is equal on both sides. Great, you see it now creates columns into both directions as we wanted. And we also want to create into the y direction as well. And I guess we might need to do some, what do you say, grafting here as well. So we use the same amount of series, or we just have to use it into the y direction. And that will be then in here. But we need to graph that. Yeah, perfect. And now they're grafted, now they have it like this. And because I don't want to have them like the structure, I want to just trim them once. And now we have 3 packs of those things in here. And we also want to now remove the points that are like overlapping or going over that, and use them or remove them from our calculations. So we just do the region or point in region, point in curve, yeah. So those are the points that we have, and this is the curve that we had here in the beginning. And this will then give us, if the relationship is on 2, it's inside, and if not, it's outside. So we do like equality here, and we do number 2, and do the relationship in here, and then use this cool pattern of that thing over here. Where do we have them? There. And this will give us our points inside of that. Great, now that we have that defined, that helps us out enormously. I would just the column spaces at least like that. And now that we have that, there are several ways of how to do the next part, but I basically want to create like lines that going upwards, and that then get cut into pieces that then get converted into like the each column for each story. So we're going to do that by, we already have that, and we now need to do an like SDL, like so we like have the start, like so we're going to create a line into the direction of the Z, and then we need to have the maximum amount of those 3. So we just do like a sort list, and we put those 2's in ones here, and then we get the values out, and the last value of this is always the biggest value, and that's what we basically want. So we just list item and do -1, and we take the last value of it, and this will be the length. So this will be then, and as you see, this is not what I wanted at all. Yeah, and it needs to be multiplied by 3.1 because that's the story height. So multiplication, put this one in here, put this one into the story height. Let me just rename this story because it's a Y. This will be then our length, like that. Perfect. And so this goes on the like will be the maximum length of the columns that we defined here. Great. Now that we have that, we want to cut them basically all up. And where are they? There, those are the ones here. Yeah, we just create a boundary surface of the points here. And this would be then our, and then there's this very nice thing under the intersection, and then the physical, and then surface curve. So we use basically the surface here as the beginning, and then the curves that we have had here, and we want to flatten that and actually graph for each. And that then gives us all very nice curves that we had here. And we very simply just trim the tree because we want to make a pull line through that, right? Like that. And it doesn't work if you just go through that because the tree structure is like not useful for that. If you actually go to Param View, you can kind of like see how it looks like. Should be looking pretty cool actually, if it loads. Hopefully this wasn't a mistake, but yeah, okay. It's a rather unique looking tree structure. And we're just gonna use it like that, and for some reason, and then we are going to trim it once, like that depth of once, and then it just creates our very nice lines here. Perfect. And now we're just gonna hide the things that we wanted to have here, and we're also gonna hide that because we want to have the boundary surface of our initial one here. Great, yeah, and this is basically already it. What you can do now is still like, we can merge those two things together. And for some reason the music is always stopping at this song, but which is fine. And here we have our curves now that can be then used as a pipe, for example, and we do just a small radii of like less than a meter. And this might take a couple of seconds, so you should have it disabled or put like a data dam between it, so it only goes off if you want it to. Otherwise it takes quite a lot of time to be calculated every time. Okay, Good. Now that we have that, we have our basic structure like that. There's some weird stuff happening here, actually. Let me actually see why. Because I think it's because we defined more. We have more range like this, so we need to put an expression here, x minus 1. So then it should work correctly, but doesn't. Let me actually double check this. So those are our points here. And for some reason it wants to go in a total different direction. Like this. And we just need to update it, obviously, and then it should work correctly. Yeah, perfect. Nice. That looks pretty great. And I just want to have like a little bit of a thickness to our surface, so just offset our extrude. Just extrude, yeah, and then use the Z direction of like a few millimeters, centimeters, I mean. And then we have a little bit like of a thicker curves like that. Great, cool. And then you obviously can change the stuff around and everything and have it to your liking. But let me just hide the things here for now and just bake this stuff and see how exactly it looks like. Great, and let's just hide the components here. And yeah, I think that pretty much, like, more or less, it's not exactly how it works, but it comes rather close to it as well. And also with the structure, I think it's pretty cool. Then you can kind of like have more reasoning to it as well. It kind of makes more sense. Great. Yes, I guess this did it. I did this today in the live stream, so you can also take a look at that, how I was coming up with it and did the idea. You can follow that as well, but for tutorial, I think that's something you can use for your things, and you can also download this stuff on GitHub as well. So yeah, so thank you very much for watching, and see you in the next one.